Good day everyone, and welcome once again to my channel. This time we are going to be having the chemistry question series for those students that are preparing to write in the forthcoming Jamb 2026 examination. If you are that student that is preparing to write in the forthcoming Jamb 2026 examination and you are finding chemistry challenging, this is a video series that will be of help to you. I would advise that you watch this video to the very end in order to learn so much within the shortest time frame for your examination. All right. So what I'm going to be doing is that in the course of treating each question, I'll be explaining a lot surrounding such question, so that in case they are bringing any question that relates to that, you should be able to attempt it with ease. So what I want you guys to do is to be very, very attentive as I run through the series. So let's start. On the board, we are having question 1. What is question 1? Which of the following is an example of a mixture? Which of the following is an example of a mixture? Firstly, we have to understand what mixtures are. Mixtures are substances that are made up of two or more constituents that are physically combined together. Mixtures are substances that are made up of two or more constituents physically combined together. Or you can redefine mixtures to be substances that are made up of two or more constituents that can easily be separated by physical methods. The physical methods I'm making reference to here are the separation techniques for mixtures, where you talk about fractional distillation, simple distillation, chromatography, decantation, filtration. All those are separation techniques for mixtures. Okay, so mixtures, there is something you should take note of. They do not have definite formula. So no definite formula for mixtures. All right. So, and mixtures happens to be one of the classes of matter. The classes of matter are three. And what are they? We have elements, we have compound, and we have mixtures. All right, element, compound, and mixture. These are the classes of matter, and these guys, they are actually called substances. In the world of chemistry, we have two kinds of substances: the pure substances and the impure substances. Now, among these three, elements and compounds are pure substances, while mixtures are impure substances. So it means that all the examples of mixtures, they fall under what? Impure substances. You understand? So now the question is, which of the following is an example of a mixture? Like I said, mixtures do not have definite formula. So let's start with the first one. Blood. Is blood a mixture? Of course, yes. Blood is a mixture. Why? Blood does not have a definite formula. It's a mixture of substances. You understand? Then we also have, what other examples of mixtures do we have? We have urine. We have soil. We have alloys. We have solutions. All right. So all these are examples of mixtures. Anything not capable of having a definite formula falls under mixtures. We still have more. All right. So looking at the options, option A is an example of mixture. So that should be our answer. Sand is a compound with the formula SiO2. Washing soda is also a compound with the formula Na2CO3 then dot 10H2O. They call it sodium carbonate decahydrate. Sodium carbonate decahydrate, that's washing soda. Then common salt is NaCl. That's our normal table salt. So if you check these other ones, you would notice that they all have definite formula. So that's one unique feature of compounds, because compounds are substances that are made up of two or more elements chemically combined together. So there must be what? Definite formula for compounds. So all these are compounds, while the only mixture happens to be blood. So the answer is A for question 1. Then let's see question 2. Question 2 is a calculation question. You guys need to be set, because calculation questions must be there. And this calculation question is coming under the gas laws. 30 cm cube of oxygen diffuses through a porous spot in 7 seconds. How long will it take 60 cm cube of chlorine to diffuse through the same pot if the vapor density of oxygen and chlorine are 16 and 36 respectively? So this is taking our minds to what is called the Graham's law, of diffusion, which says that the rate of diffusion or effusion of a gas is inversely proportional to the square root of its vapor density. Don't stress yourself over the law. All you simply do is to know the formula to use to getting your answer. And what's the formula? Now the formula is given as R1 over R2. Please, you need to know this formula. It's very important in calculating questions on Graham's law of diffusion. R1 over R2 is equated to root M2 over M1, then is equated to root D2 over D1 is equated to T2 over T1. This formula will help a lot in calculations involving Graham's law of diffusion. The M here is molecular mass, then the D here is density, while the T here is time. Then there is still another thing that you need to take note of in calculations involving Graham's law. And what is that? Rate of diffusion is equated to volume over time. This thing is very important, very, very important, especially when volume of gases are given in the question. You need to work with this. So you must need to know this. Rate is equal to what? Volume over time. So how do we now calculate this? Firstly, let's bring our parameters out. The parameters: 30 cm cube of oxygen. So volume of oxygen is 30 cm cube. Then diffuses through a porous spot in 7 seconds. So the time it took oxygen to diffuse is 7 seconds. Then how long will it take? So we are interested in finding the time that it will take for chlorine, for 60 cm cube of chlorine. So our volume of chlorine is 60 cm cube. You see it now, chlorine is written as Cl2, which is chlorine gas. So the volume is given and we are told to calculate the time it will take this 60 cm cube of chlorine to diffuse. Now, if the vapor density of oxygen and chlorine are 16 and 36 respectively, it simply means that the density of oxygen is what? 16. So density of oxygen is 16, then density of Cl2, which is chlorine, is 36. So the formula we are to use is RO oxygen over RO Cl2, because these are the two gases. I can decide to write my Cl2 above and write the oxygen beneath, whichever one. But if I write it in this pattern, just know that you are to write this one at the top and write this at the bottom. Anything you want to write here, make sure that it is ascribed to this at the top here and this one at the bottom. See what I'm trying to say? Now we are given what? Density. So we have to work with what? D. Then D of what? Cl2. So dCl2 over dO2. So you see, they are like, you see it now, not directly opposite, adjacent to each other. So I would want you guys to take note of this. So firstly, what is the rate of diffusion of oxygen? We will need to use this formula to get it. The formula is rate of diffusion of oxygen is equated to volume over what? Time. What's the volume for oxygen? 30. So in place of volume, 30 over what's the time it took oxygen? 7. So the rate of diffusion of oxygen would now be what? Let's use our calculator. So in the hall, your calculator will be in the system. So 30 divided by 7 is 4.29, approximately 4.29. This is the rate of diffusion of what? Of oxygen. Okay, then we can now plunge in our values, because now we know we can use this now. We know the rate of diffusion of oxygen. We don't know the rate of diffusion of chlorine. We can get it. We know the density of both of them. So it means we can get the rate of diffusion of chlorine first. If we can get this one, then we cannot get the time because we know the volume of chlorine. Just to get the rate first in order to get the time we are told to find. You understand? So let's use this formula to get the rate of diffusion of chlorine. We can easily get that. So how do we go about it? How do we go about it? It becomes what? This guy, rate of diffusion of oxygen is what? 4.29 over x, because this is what we want to get first. Then is equated to root. Density of chlorine is what? Is 36 over density of oxygen is what? 16. So when you divide this by this, what would you get? 36 divided by 16 is 2.25. So from here, we can continue here now. 4.29 over x is equated to what? Is equated to 2.25 root 2.25. So from here, what are you supposed to do? This root is the problem. How? Because in Jamb, your calculator is basic, so there is no square root. So what are you supposed to do? You know that square root of a number is simply the number that when you multiply by itself, it gives you that number. What I'm trying to say is square root of 4 is 2, right? Because 2 times 2 will give 4. Square root of 36 is 6, because 6 times 6 will give 36. So what number would you multiply by itself to get 2.25 is what should be the square root of 2.25. So how do we go about it? Now, the simple trick is, since you don't have square root, I would advise that you try numbers. Now we know 1 times 1 is 1. So you just increase it, use decimals. You can say 1.2 times 1.2. If it doesn't give you 1.3 times 1.3, just be trying it. 1.4 times 1.4, 1.5 times 1.5, you will get it. But you have to be very fast. You understand? That's just the trick. So this becomes 1.5 times 1.5. It gave me what? 2.25. So the square root of this is 1.5. So 1.5, then 4.29 over what? X. So when you cross multiply here now, it becomes 1.5x is equated to what? 4.29. You get it now? So when you divide both sides, x becomes 4.29 over what? 1.5. So when we do that, our x will now be what? 4.29 divided by 1.5. 4.29 divided by 1.5. We got 2.86. 2.86. So this is known to be our rate, the rate of diffusion of what? Of chlorine. This is the rate of diffusion of chlorine. So now that we have gotten it, we can easily obtain the time, because that's what we are told to calculate. How long will it take? 16 cm3. So now you run to this place. Rate of diffusion of what? Chlorine is equated to volume over what? Time. What's our rate? Our rate is given as, we got it just now, 2.86 equated to, what's our volume? Our volume is given as 60. Then what is our time? That's what we are told to calculate. So when you cross multiply, it becomes 2.86 T equated to 60. So we have to divide both sides by 2.86. That becomes 60 over 2.86. So with the help of our calculator, we can get the answer. 60 divided by 2.86 will give us 20.9, which is approximately 21 seconds. So do we have it in the option? Of course we do. Option C, which is 21 seconds. So some persons, they would be like, what time are we having in the hall to calculating all this? It's because of the fact that I'm explaining. That's the reason why the stuff is very long. But then I would advise that whenever you are confronted with a question like this, make sure you skip the question, attempt other questions that are straightforward. You can come back and getting your answer by solving. All right. So what I advise, just pay attention on those ones that are straightforward and skip those calculation questions, then you come back for them again. By that time, you will now be very settled. That's time management. All right. So the answer is option C. Let's see the next question. The question 3. Which of the following gases will diffuse fastest when passed through a porous plug? A. Propane, B. Oxygen, C. Methane, and D. Ammonia. First thing that you need to take note of is that the rate of diffusion of a gas is dependent on the weight or the molecular mass of the gas, meaning that those gases that are having high molecular weight or high molecular mass, they tend to diffuse at a very slow rate. So slow rate of diffusion. So the higher the molecular mass, the slower the rate of diffusion. While the lower, this one is higher, then the lower the molecular mass, the higher the rate of diffusion. Take note of this. It is very, very important. So molecular mass is related to density also, meaning that molecular mass is given as 2 times density. Please note this relationship. So this relationship is a direct relationship. If you increase molecular mass, you would certainly increase density of the substance. If you reduce molecular mass, density will what? Be reduced. So it's just direct relationship. All right. So in case they ask a question without mentioning molecular mass and then they are mentioning density, anything that works for molecular mass will certainly work for density in terms of this question. Let's now bring out all of the gases given in the question and we'll now make comparison. The first gas is propane. The second is oxygen. The third is methane. And the fourth is ammonia. So let's get their respective weight. Let's first get their formula. The formula is C3H8, that's propane. You can do well to watch my video class I made on organic chemistry. Then you better understand this aspect because propane is an organic compound under the alkanes. So this is the formula C3H8. Oxygen gas is O2. Methane is CH4, still an organic compound. Then ammonia is NH3. So let's get their relative molecular masses. For C3H8, how do we go about it? Now, the relative atomic mass of carbon is 12, relative atomic mass of oxygen is 16, relative atomic mass of hydrogen is 1, relative atomic mass of nitrogen is 14. So with this, you can get your answer. For this one, C3H8, it becomes 3 times 12, which is this 12 times 3 plus 8 times 1. 8 times 1. 3 times 12 is 36 plus 8 is 44. So for propane, its weight is 44. That's molecular mass 44. Then oxygen is O2, meaning 2 times 16. You know, the relative atomic mass of oxygen is 16. So when you get it, it becomes 32. 2 times 16 is 32. So oxygen is 32. Then methane is CH4. Carbon remains 12 plus hydrogen is 1. 1 times 4 is what? Is 4. Then 4 plus 12 is what? Is 16. So methane is 16. Then ammonia is NH3, which is 14 nitrogen. Nitrogen is 14 plus hydrogen is 1 times 3 is what? 3. 14 plus 3 is 17. So we have 17 here. Remember I said the higher the molecular mass, the slower the rate of diffusion. While the lower the molecular mass, the faster or the higher the rate of diffusion. So in this case, which one would diffuse? Because according to the question, the one that would diffuse fastest, must be the one that has the lowest molecular mass. So looking at this, 44, 32, 16, 17, which one has the smallest or the lowest is methane. So the correct option is option C. I hope this is clear. All right. So let's see the next question. Question 4. a hydrated salt or formula. Now we are giving this formula to be the formula of the hydrated salt, and then contains 45.3% by mass of water of crystallization, meaning the mass of water of crystallization, the mass of water of crystallization is given as 45.3%. Calculate the value of x. So we are told to calculate the value of x. I'm going to give you guys the shortcut to calculating water of crystallization in terms of the number of moles. Now, the shortcut is water of crystallization, meaning talking about the moles of water of crystallization now, is given as MW times WA over 18 times MA. Just take note of this formula, it will help you a lot. Where this MW here means mass of water, then WA means molar mass or molecular weight, molecular mass of anhydrous salt, of the anhydrous salt. Then MA means mass of anhydrous salt. Anhydrous salt. When we say anhydrous, the word anhydrous means there is no water, so without water or dried. Now, we are given the mass of water of crystallization to be this. Forget about this percentage, you can replace with G, it's the same thing. But since they went with percentage, you know that the complete percentage is 100. So it therefore implies that if the mass of water of crystallization is 45.3 of the percentage, then if you remove this 45.3 from 100, 45.3 from 100, then what should we get? 45.3 from 100 is 54.7. So it means that the mass of anhydrous, which is the salt without water, is given to be 54.7% by mass. You understand? So we know the mass of water as 45.3 and the mass of the anhydrous salt as 54.7 when you subtract this from 100. All right, so we have known our mass of anhydrous and our mass of water, right? Then what are we left with? We are left with the molar mass, which is molecular mass of anhydrous. That's the essence of we giving all these in brackets, because the anhydrous means if you remove this whole water from this compound, you should be left with this one. This salt is called the anhydrous salt. You understand? So if I bring it out, MsO4, and I want to get the molecular mass of only this guy, in order for me to get my WA, because I know my MA now. My MA is what? Is 54.7, and my MW, which is mass of water, is given in the question as 45.3. So we're able to use the mass of water to get that of the mass of what? Of the anhydrous salt, because we are given in percentage. That was why I subtracted this from 100 to get the mass of what? Anhydrous. You understand? So we are left with the molar mass of anhydrous. So let's get that one using this now. What's our M? 56. So it becomes 56 plus, what's our S? Our S is 32. 32 plus, what's our oxygen? 16. So 16 times 4, 64. So when we sum up everything here, let's sum up 56 plus 32 plus 64. We are going to obtain 152. So 152. So what's our 152 now? It is our WA. So bringing all of them out, our WA is 152. Then our MA is what? 54.7. Our MW is what? Is 45.3. So we can get our answer now. All we simply do, we just work with this. MW is what? Is 45.3 times WA is what? Is 152 over 18 times MA. What's MA? MA is 54.7. Then let's get our answer. With the help of our calculator, we should obtain 45.3 times 152. That is 6885.6. 6885.6 over then 18 times 54.7. 984.6. 984.6. So when we do our division, we should obtain 6885.6 divided by 984.6. That should give us 6.99. So this is approximately what? 7. So do we have 7 in the option? Option C. So that's how you go about calculating for water of crystallization. This formula is the key formula. Please note it and note what each of them represent. It's because of the fact that I'm explaining. That's the reason why it's taking time like this. But when you are in the hall, you should be very, very smart. Just use the formula and then you get your answer. Question 5. What is question 5? Permanent hardness of water can be removed by adding dash. So this is taking our minds to hardness of water. Now, when we say hardness of water, water is said to be hard when it does not easily lather or foam with soap. That's what it means by hardness of water. And we have two types. We have the temporary hardness, and we have the permanent hardness. Now, temporary hardness is called temporary because it can easily be removed by boiling. So compounds that cause temporary hardness are CaHCO3, calcium hydrogen carbonate, and MgHCO3, magnesium hydrogen carbonate. These are the two compounds that can cause temporary hardness. That of permanent hardness, compounds that can cause it are CaSO4, MgSO4, that's calcium sulfate, magnesium sulfate, then iron sulfate, then calcium chloride, and magnesium chloride. These compounds can cause permanent hardness. Now, the question is, permanent hardness of water can be removed by adding. So the method for removing, for temporary, what can be used to removing it? Two standard methods. And what are they? Addition of calcium hydroxide, slate lime, and also by boiling. Permanent hardness cannot be removed by boiling. That's the reason why it's called permanent. Then what are the methods for removing permanent? By addition of caustic soda. Caustic soda is sodium hydroxide, NaOH. Then by the addition also of washing soda. Addition of washing soda can be used. Addition of washing soda, which is Na2CO3.10H2O. That's washing soda. Then we have permutate and zeolite method. Permutate and zeolite method. This one is ion exchange resin. That's what it involves. But then these are the three main, and anything that can remove permanent hardness can also remove what? Temporary. Take note of that. So all of these methods can be used to removing temporary, but the two standard methods remains this. So methods that can be used to removing temporary cannot be used to removing permanent. It is only methods that are used to removing permanent that can be used to removing what? Temporary. So do we have any of those in the option? Let's check. Permanent hardness of water can be removed by adding bleaching powder, no. Chlorine, no. Washing soda, yes. So the answer is option C. Then the next question, question 6. Question 6. We are asked, when a few drops of water is added to blue anhydrous cobalt 2 chloride. The color changes to, now this is known as paper test. Paper test for water. Paper test for water. Now we have two papers that can be used to test for the presence of water. The first is anhydrous copper 2 sulfate paper. Then we have the other as anhydrous cobalt 2 chloride paper. Now the color change is this. Initially, when both of them are anhydrous, meaning without water, the color of this copper 2 sulfate paper is white. Then while this one is blue. So when water is added to this, it will not change from white to blue. That's for copper 2 sulfate paper. Then that of cobalt 2 chloride paper, it changes from blue to pink when water is added. So this is the question that we are asked, the other one here. They said when a few drops of water is added to blue anhydrous cobalt 2 chloride, the color changes to, so it changes from blue to what? To pink. So do we have pink in the option? Yes, option B. That's our right answer. Question 7. The solubility of 20.2 gram of potassium triazonitrate 5 in moles per dm cube dissolved in 100 gram of water at room temperature is, now this question is coming under solubility. Whenever you see questions like this, just know that you are to work with the Riemann formula for calculating solubility, and it is given as solubility in moles per dm cube is equated to 1000 m over mv. Please remember this formula. Remember this formula is very important. So our m here is mass of solute. That's a small m, mass of solute. Then while the big M is molecular mass, which is big M of solute. Then while V there is volume of solution, usually the volume of the solvent given, V. Then let's see how we can calculate it. So how do we now get the molecular mass of the compound? Because the compound that was given was potassium triazonitrate 5, which is KNO3. This is the formula of potassium triazonitrate 5. So let's get the molecular mass of this guy first. What's potassium? Potassium is 39. So 39 plus what's nitrogen? 14. 14 plus what's oxygen? 16. So 16 times 3. This should become 39 plus 14 plus 48. When we sum up everything here, we should obtain what? Let's sum it up. 39 plus 14 plus 48 would obtain 101. 101. So this is gram per mole. 101 gram per mole. So that's our potassium nitrate. Then we know the mass. What's the mass given? The small m given. The small m is 20.2 grams of it. Then what about the volume? The volume, anything you are giving of water, just know that is the volume, irrespective of the units given there. So our volume is 100 cm cube. So what do we do now? We run to this formula. That's this cm cube here is actually equivalent to grams of water. So like I said, anything you are giving of water, just work with it as the volume. You understand? So it becomes what? We run to this formula because we want to calculate now. So solubility is given as 1000 times, what's our small m? 20.2 over big M. Big M is what? 101 times volume is what? 100. So when we do this calculation now, it becomes 1000 times 20.2 that is 20200 over 101 times 100, that is 10100. So when we carry out the division, we are to obtain what? We are to obtain 2. So our answer to this question is 2.00. So option D becomes the correct answer. I hope this is clear. So please take note of this formula, is very important. Then let's see the next question. In question 8, we are told that the colloidal dispersion of a liquid in a solid will form dash. So how do we go about this? This thing is very easy. When you hear colloids are forced solutions. So you have the dispersion medium and the dispersed medium. I want to drop a code that can be of help to you. Now we have dispersion medium, and we have the dispersed medium. Okay, dispersion medium and dispersed medium. Now everything I'm to write here are going to be dispersed in everything that I'm to write here, but this is the code. My code is access F, then here is G L L G L, then here is L S L S G. That's my code. Now this thing means aerosols. This is sols and gels. This is emulsions. This is smoke, and this is foam or lather. When you are washing, what comes out? Foam or lather. So this is gas, this is liquid, this is gas, and this is liquid. This is liquid, this is solid, liquid, solid, and gas. So everything here is dissolved or dispersed in everything here. You see this arrow pointing? It means everything here should be dissolved or dispersed in everything here. What I'm trying to say in effect, what should be correct about aerosols is liquid dispersed in gas. What should be correct about sols, only sols, is solid dispersed in liquid. You know, these two, I actually grouped them for a reason. Sols are liquid forms of gels, while gels, take note of this, are solid forms of sols. It's just like fats and oils. You know, fats are solid forms of oils, while oils are liquid forms of what? Fat. So sols are liquid forms of gels, while gels are solid forms of what? Sols. So this one is solid, this one is what? Liquid. So what I wrote here is only to sols. This one, which is solid in what? In liquid, is sols. Then opposite, meaning if I write liquid here, and I now write solid, meaning I swap their positions. So liquid here, solid here, it should be for what? Gels. So liquid in solid is gels, while solid in liquid is sols. So take note of that. Then while emulsions, which is correct, liquid in liquid, then smoke, solid in gas, then foam, gas in liquid. You get the point now? So aerosols, they are like the sprays. So all those insecticides, anything spray falls under aerosols. Like we have the fog, it falls under aerosol. Fog falls under aerosols. Then soils and gels, you have those starch, algal rose. Then under emulsions, we have milk, we have paint under emulsions. So just take note of this. Then look at the question. You can now easily get our answer. The colloidal dispersion of a liquid. So liquid in solid, check. This is liquid in gas, this is solid in liquid for sols, and liquid in solid for gels. So what was the question? They said liquid in solid. So liquid in solid is for what? Gels. So what should be your correct answer? It should be what? Option B, gels. You understand? So that's how it basically works. Take note of this shortcut to help you a lot. All right. So the correct answer is option B. Let's see question 9. Question 9. Please take note of this. Question 9 is a question under electrolysis. A question under electrolysis. Now, electrolysis, the Remer formula for electrolysis is given as atomic mass. Atomic mass is given as charge times farad. Then mass deposited is given as current times time. So this is the Remer code, the Remer formula. So what do you do here? You just cross multiply, meaning atomic mass times current, because this guy will multiply everything here. So times current times time is equal to mass deposited, which is this, times charge times farad. So this is the formula that you can use to calculating questions involving what? Electrolysis. Now we are given the mass of silver deposited when a current of 10 amperes. So our current, not to waste much time, our current is what? 10 amperes. Then continue, is passed through a solution of silver salt for 4,830 seconds. So our time is 4,830 seconds. Then we are told to calculate the mass, right? So the mass is unknown. That's what we are told to calculate. Then what about the charge? The charge of silver is usually what? +1. Why? Silver is written as Ag+, so it carries a positive charge, and then there is no number, so it's assumed to be +1. Then our farad is given, even from the question in bracket, we are giving our farad to be 96500 as our value. Then what about the atomic mass of silver? Atomic mass of silver is given as, in bracket here, is what? 108. So we can easily get our answer from this one. We can get our answer. All you simply do, just substitute the values. Let's go. Atomic mass is what? 108 times, what's our current? Current is 10 times, what's our time? The time is already in seconds. Please take note. If this time is in minutes, what are you supposed to do? You multiply by 60. But if it is in hours, you multiply by 3,600. So if you are converting from minutes to seconds, you simply multiply the value by 60. But from hours to seconds is by multiplying the value with 3,600. So I've written this times 10, then times what? 4830. Then equal to, the mass is what we are told to find, which is x, then times what's the charge? Charge is 1 times what's farad? Farad is 96500. So when you multiply everything here, let's multiply everything there first. So it becomes 108 times 10 times 4830. Then you divide it by 96500. Then we obtained our mass to be 54 approximately. So do we have 54 in the option? Yes, option B. So you see how easy it is. It's just for you to work with this formula and then you are good to go. Let's see the next question. Question 10. An increase in entropy can best be described by, first and foremost, what is entropy? Entropy is the measure of randomness or disorderliness of a system. The measure of randomness or disorderliness of a system. Now there is very important thing that you must take note of about entropy. Entropy could be positive or it could be negative. It is denoted with the letter S. When entropy is positive, it means that there is high degree of disorderliness. When entropy is positive, high degree of disorderliness. But when entropy is negative, there is low degree of disorderliness. Low degree of disorderliness. Then when it is positive, high degree of disorderliness. Now we can easily get our answer. An increase in entropy, meaning increase in entropy, can be best described by when you increase entropy, meaning when you increase disorderliness. You know, entropy is what? Disorderliness, measure of disorderliness. So when you increase disorderliness, what would happen? An increase in entropy can be best described by, you see it now, these are the options. A, freezing of water. Freezing of water, is it orderly or disorderly? It is what? Orderly. So this can never be the answer because we are looking for the one that is highly disorderly. So B, solidification of water. Is it the same thing as freezing of water now? So it's still what? Orderly. Then C, mixing of gases. Mixing of gases is random, so that is disorderly because gases dey move in random motion, so it's disorderly. Then condensation of vapour is the conversion of gas to what? Liquid. That's orderly because gases, look at the states of matter: solid, liquid and gas. Which one do you think has the highest degree of disorderliness? Is gas. Then what about orderliness? Solid. So it means if you are converting gas to liquid or you are converting it to solid, it means that you are bringing about orderliness. You understand? And the process of converting gas to liquid is called condensation. So condensation is orderly, but mixing of gases is disorderly. That's what indicates increase in entropy amongst the options. So the best option to go with is option C. That's the correct answer. All right. Then let's see the next question. The next question, question 11. In question 11, we are given an equation or a reaction, and then the reaction is CH4 plus Cl2, then CH3Cl plus HCl. Then we are asked the major factor that influences the rate of the reaction above. This compound happens to be methane. It falls under the members of the alkanes, and the members of the alkanes, they undergo substitution reaction majorly with the halogens, and the reaction occurs in the presence of ultraviolet light. Ultraviolet light. So since it occurs in the presence of ultraviolet light, it means that light is functioning as the catalyst to increasing the rate of the reaction. That's the reason why the reaction is called photocatalysis, meaning that light influences the rate of the reaction. So the correct option to this question is option C, which is light. All right. So next question, question 12. In question 12, we are told that the oxidation number of iodine in KiO3, this is a compound. So if you have not watched my video lesson I made on determination of oxidation number, do well to watch that video lesson. It will help you. Now, this is a compound you equate to 0. That's the rule. Next, we are told to calculate the oxidation number of iodine here. Iodine is I, so it's unknown. Potassium is a group 1 element. In combination with other elements, it exists in the +1 oxidation number. Then while oxygen in most compounds is -2. You see where I'm bringing all these numbers from? From the rule I dropped in that video lesson. It's not hard. Oxidation number of oxygen in most compounds is -2, except peroxide, which is -1. Hydrogen in most compounds is +1, except hydrides, which is -1. So this happens to be a group 1 element. So since it is in combination with other elements, it should have the +1 oxidation number. Any group 1 element is +1 when they are in combination with other elements. So in this case, the next step to take is that since there is no number here, you just simply go with the +1. If there was a number here, you would multiply it by the charge. then you now write it there. So this is what? X, and this is what? 3 times minus 2 is what? Minus 6, equal to 0. Then x, you bring out x, plus 1 minus 6 is what? Minus 5, then equal to what? 0. Then x, if you collect like terms, x will now be equated to 0. Then when this minus 5 crosses to this side, it turns plus 5. So this should become what now? 0 plus 5 is what? Is plus 5. So the oxidation number of iodine in this compound is plus 5. Do we have it in the option? Yes, option C. So let's see the next question. Question 13. Hydrogen bomb is based on the principle of. Now, in nuclear reactions, we have two divisions. We have the nuclear fission and we have the nuclear fusion. Nuclear fission has to do with splitting, while nuclear fusion has to do with combination. Both of them, they release energy. When even comparing nuclear reactions to that of chemical reactions, now chemical reactions release energy, but not as large as the energy released from nuclear reactions. So nuclear fission and nuclear fusion, which releases a higher amount of energy, it is what? Fusion. Fusion releases a higher amount of energy. And examples of processes that use or utilize the principle of nuclear fusion includes hydrogen bomb and energy generated by the sun. All right. So it works based on the principle of nuclear fusion. While that of nuclear fission, you have atomic bomb. Atomic bomb works based on the principle of nuclear fission. So they asked, hydrogen bomb is based on the principle of, it's obvious now, it is nuclear fusion. Nuclear fusion. That's option B. I hope that is clear. Then question 14 is a calculation question, and it is coming under one of the calculation areas in chemistry that is so easy. What is the percentage by mass of oxygen in, this is the compound, Al2SO4 3.2H2O. When some students just see this compound, the next thing is just to guess, but the era of guessing is over. Now looking at this, we are told the percentage by mass of what? Oxygen. So what we are interested in this compound is to calculating the percentage by mass of oxygen. The first code I always give to students under this is when you have bracket and number outside, try to open the bracket so that it will make your work to be very easy. So the first step to take is you write Al2, open this bracket with this number. So the number will affect the entire substance in the bracket. So it becomes S3, that's S times 3, S3. Then O4 times 3 is what? O12. You understand? 4 times 3 is 12. Then dot 2H2O. You understand? So this is what we are going to be working with now to make our work to be very, very easy. Then we are told to calculate the percentage of what? Of oxygen. So what should be written above should be what you are told to find. What should be written below should be the entire substance you are given. Then you now multiply by what? 100. Very easy. Anything you are told to find, write it above. What you are given, you write it beneath and you multiply by 100. What am I told to find? Oxygen. How many oxygen do you have here in total? In total, we have 12 here and we have 2 here. So 12 plus 2. 12 plus 2. That is 14. 14. So we have oxygen to be what? 14. Because this is 12 and this is what? 2. That's a total of 14. Then which other thing again? We are not going to write this entire substance now beneath. So it becomes Al2, then S3. No, we are working with this new one now. It's still the same thing, but for simplicity's sake. Then S3, then O12, then dot 2H2O. The next thing to do is we will now get the weight of oxygen. Oxygen is given to be 16. So we can do it here. O14 should be what? 16 times 14 to get the weight. So 16 times 14 with the help of our calculator, 16 times 14 is what? 224. So 224. Then the entire substance, which is the one written here now, the entire substance, let's get that one. Al2 S3 O12 dot 2H2O. So in this case, let's get it. Aluminium is what? Is 27. So 27 times 2, which is this 2, plus sulfur is what? 32. So 32 times 3 plus oxygen here is 12. So it becomes 12 times 16. Then plus this dot. Don't be confused. This dot means plus. You still continue your addition. So plus. Then this is 2 in bracket. Hydrogen here is what? 1. 1 times 2. So 2 times 1. Then plus what? Plus 16. There's no number here. So 16. That's 2 times 1, which is this 2 times 1. Then 16. You understand? So let's get it. It becomes 27 times 2 with the help of our calculator. 27 times 2. 27 times 2. That should give us 54. So write 54 there. 54 plus this 3 times 2 is 6. 3 times 3 is what? 9. So it becomes 96. Then plus 12 times 16. 12 times 16. That should give us 192. So 192. Then plus this entire substance. 2 times 1 is 2 plus 16 is 18. So everything here is 18. Then 18 times 2 outside. 18 times 2, 36. All right. So we have already gotten all our values. It's just to add up now. So let's add up everything. Adding up should be 54 plus 96. You know, when you're in the hall, you have to be fast too. No, it's because I'm explaining. Plus 192. Plus 192. Then plus 36. That should give us 378. So we have obtained 378. Now, what did we get as oxygen? 224. So 224 over 378 times what? 100. It's very easy. Now, this should give us 22400 when you multiply over 378. So 22400 divided by 378, that should give us 59.25. 59.25. That was what we got. 59.25. Do we have it in the option? 59.25. Do we have it in the option? Yes, it is option D. 59.25. I hope that is clear. If it's not clear, rewatch it. Rewatch this video lesson to master it. Okay, this principle that I used here is the same principle that you can use for others. Okay, so that's that about that. Then let's forge ahead. Question 15. Question 15 is, what is the molecular formula of a compound with empirical formula CH2 and vapor density 42? So we are told to calculate what? The molecular formula. Molecular formula is actually the true formula of a substance, while empirical formula is what represents the simplest whole number ratios of elements that make a compound. So this is molecular formula is equated to empirical formula. This is the formula for finding molecular formula. Empirical formula all in N. I can write this by using MF is equated to EF all in what? N. So this is what connects the molecular formula to the empirical formula. So you need to calculate for the N value, because if the N value is unknown, you can't get your molecular formula. So for you to get the N value, you have to work with empirical formula all in N. You must equate to what? Molecular mass. Molecular mass. That is, if the molecular mass is given in the question, you just write it directly. Sometimes they might not give you the molecular mass directly in the question. You might be given density. Remember I said that molecular mass is equal to what? 2 times density. That's the relationship. So it means that anything you are giving for density, you have to multiply by 2 in order to get the molecular mass, because you must work with molecular mass and not density. So in this case, for we to now get the molecular formula, we have to get the N value from the empirical. So how do we go about it? Let's now get started. Now, what's our empirical formula? CH2. So we'll write this. We'll first calculate for N first, which is CH2, our empirical formula, all in N, equated to what? Molecular mass. But were we giving molecular mass? No, we are giving vapor density. So what do? 2 times density gives molecular mass. So since our density is what? 42, our molecular mass will now be 2 times 42, and that should give us what? 84. 84. So our molecular mass is 84. So we can get our N. Remember that the relative atomic mass of carbon is what? 12. So it becomes 12 plus relative atomic mass of hydrogen is 1, then times 2 is what? 2. Then all in what? N, equated to 84. So 12 plus 2 is what? 14. 14N equated to 84. So our N therefore will be 84 divided by 14. So 84 divided by 14 will be our N. We got 6. So our N is 6. If our N is 6, we can run to our molecular formula, which is this formula now. MF, molecular formula, is equated to, what's our empirical formula? Our empirical formula from the question remains CH2. So we write it CH2, then all in what? N. Now we know our N value, right? What's our N value? 6. So since our N value is 6, it becomes molecular formula equated to what? Equated to CH2 all in what? 6. Because our N is 6. So we can open the bracket with that number now. It becomes molecular formula is equated to what? 6 times carbon is C6. Then this 2 times 6 for hydrogen is what? H12. So it therefore implies that our molecular formula is what? C6H12. Do we have it in the option? Yes, we do. Option A. Hope it is clear. So let's forge ahead to the next question. Question 16. In the periodic table, what is the property that decreases along the period and increases down the group? Now, there is something that is called periodic properties of elements. And what are they? We have the first to be electron affinity. We have electron affinity. We have ionization energy. Ionization energy. We have atomic radius. Atomic radius. We have electropositivity. Electropositivity, and we have electronegativity. Now, these are the periodic properties of elements. By definition, electron affinity is the energy that accompanies the addition of electrons to a neutral gaseous atom that is isolated. Then while ionization energy is the energy that is required to remove or pull off electrons from a neutral gaseous atom that is isolated. Then atomic radius is half the distance between two nuclei of atoms in a bonded pattern. Then electropositivity is the ability of an element to lose electrons and become positively charged. Then electronegativity is the ability of an element to gain electrons and become negatively charged. So those are their definitions. But what about their trend? Now, electron affinity, ionization energy, and electronegativity, I group them together. You see their grouping. Now, these three, they increase across the period and they decrease down the group, meaning that this RAP stands for increases across period, decreases down group. Then atomic radius and electropositivity, they are in one group. They decrease across the period and they increase down the group. Take note of this, is very important. The only two that dap. So if you know that these only two are the ones that dap, automatically the other should be what? Ap, which is RAP. You understand? So, and never should you be having the same trend occurring, meaning here is decreasing, the other should be increasing. Here is increasing, the other should be decreasing. You are not to be having increasing or decreasing. That's just a code. All right. So what was the question? In the periodic table, what is the property that decreases along the period, meaning across the period, and increases down the group, meaning the one that DAP and IDG. Which one? Atomic radius and what? Electropositivity. But do we have electropositivity in the option? No. We only have what? Atomic radius. So your answer becomes option D. It's very easy. All right. So that's how you attempt questions like that. Then let's forge ahead to looking at the next question. The next question is the element with the electronic configuration 1s2, 2s2, and 2p3 is, I can say that this is one of the simplest questions that Jamb can possibly ask any student. How? The element with the electronic configuration, this is the electronic configuration, and they are asking for the element. It's very easy. Just add up everything that you have as powers here. So 2 plus 2 plus 3 will give us what? 7. What element has the atomic number of 7? The atomic number of 7. When you are reciting your first 20 elements, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, right? Good. So it means nitrogen has an atomic number of what? Of 7. So hence the element should be what? C, nitrogen. Hope you got that. So the next one is still related to that we looked at just now. The next, 18. If the electronic configuration of an element is this, that's 1s2, 2s2, and 2p5, how many unpaired electrons are there? How many unpaired electrons are there? Normally, if you want to draw the box of S, you know we have SPDF as orbitals. This one, S, has this kind of box, only one space. Then P has box split into 3 parts like this. Then D has box split into 5 parts. Then F has box split into 7 parts. You see it now? So this one has only 1 part. That's the reason why 1s we have what? Just a box like this. That's 1s. And then how many electrons are there? 2. So you fill it like this. They are paired. This one, 2s. How many electrons are there? 2. Something like this. Then next, 2p. Because of this p, you know p is 3 parts. So you have to draw a longer one so that it will not be 3 parts. So 2p. How many electrons are there? 5. So when you are filling, there's a rule you need to obey. Those ones that have different parts, number of parts, you have to obey a rule whenever you are putting electrons within. And what's that rule? They call it the Hund's rule of maximum multiplicity. Now, don't be worried about that. What it states is that when you are filling electrons, you have to fill singly before you now start pairing. Meaning you don't just pair like this. It's wrong for you to pair instantly. No. You don't do that. What are you supposed to do? You fill singly before you now come back and start pairing. So it becomes what now? For 5 electrons, it will now be 1, 2, and 3, then 4, and what? 5. You see it now. So we fill singly before we now came back and started pairing. That's the rule. Whenever you want to fill in any of these three, you get the point now. But for just this one that has only one box, you just pair instantly. So in this case now, how many unpaired? We have a pair here, we have a pair here. But in this case, we have what? We have only one unpaired. So how many unpaired electrons are there? Amongst these that I have represented for these guys, how many unpaired? This is paired, this is paired, this is paired, this is paired. Only one unpaired. So the correct answer becomes option A. I hope that is clear. Question 19. How many neutrons are present in an atom of mass number 36 and atomic number 17? You must have seen an atom X represented in your textbook. Then you write A here and write Z here. They usually call this mass number, or you call it atomic mass. Then they call this atomic number, or you can call it proton number. Now, for you to obtain the neutron number, you have to subtract Z from A. So neutron number, which is neutron N, is given as A minus Z. So that's how you can get your number of neutron. So what were we given? We were given the mass number to be what? 36. So our mass number A is 36, then minus our atomic number is 17 to get the number of neutrons, because we were told how many neutrons are present. So 36 minus 17 is what? 19. That's our answer. So option C becomes the correct answer. So let's look at question 20. Question 20. What is the valence share electron configuration of the element with atomic number 17? Understand this question. What is the valence share electron configuration? Valence means outermost. Outermost. That's what they are asking. Outermost share electron. So firstly, how many electrons are we dealing with? How many electrons are we dealing with? We are given the atomic number to be 17. Since we are not dealing with charge, then the atomic number being 17 is the same as the number of electron, because atomic number is also called what? Proton number. And when the atom in question is neutral, the proton number is the same as the electron. You get the point? So it means we have how many electrons there? The total number of electrons, total electrons are 17. So what did they ask us? What is the valence share electron? That's what they are interested in. Valence share electron. Now, since we have a total of 17, first share, which is K share, takes maximum of 2. The next share takes maximum of what? Of 8. 8, which is a total of 10 now. Then we should be left with 7. 7. So this is 2, 8, and what? 7. 2, 8, and 7. So a total of 17. But what is the valence share? This outermost share here is called the valence share. This is called valence share. How many electrons are there? 1, 2, 3, 4, 5, 6, 7. So we have a total of how many valence electrons? We have a total of valence electrons of 7. So that's what they are interested in. They said, what is the valence share electron configuration of the element with the atomic number 17? So we are only interested in the valence share. But mind you, we have this sequence of 1s, 2s, 2p, 3s, 3p. Always have this in your head. 1s, 2s, 2p, 3s, 3p. You understand? Now, looking at this, remember I said S will take only 2. P will take maximum of 6. D will take maximum of 10. F will take maximum of 14. Have this also in your head in terms of electrons. So let's go. By the total number of electrons, total number of electrons is 17. So it becomes what? 1s, how many? 2. 2s, 2. 2p, 6. Should we stop? No, because 2 plus 2 is 4, plus 6 is 10. We are running towards 17. So the next is 3s2. You know s can only take 2. Then it's 12 now. Then 3p, we can put 5 there. because now we are left with only 5, and you know P can take maximum of 6, so it can take 5. All right, so we are left with what? This. So this guy is the electronic configuration of the total electrons 17. But what did they ask us? Many students will end up selecting the wrong option while smiling on this particular question. Now they will go with this one because this is the main electronic configuration of the total electrons. And if you should check the option, is there. Option A is there. But this is not the answer. Why? Because the question is valence shell electron configuration. Remember that in our shell, the valence shell had how many electrons? It had 7. So if you are counting, this is 2 plus 2 is 4 plus 6 is what? 10. So 10. Then the last ones that we have here, because this 3 means the last shell, in this case 1, 2, 3. 1, 2, 3 meaning the third shell. So this 3 means the third shell. So in the third shell, which is the valence shell here now, how many electrons are there? 7. So it means you must start from here. 2 plus 5 now is what? 7. So this 7 that you have here now is actually this 2 plus 5. So they are asking for the valence shell electron configuration. So it means that you are only interested in the valence shell, which happens to be this one. So you just pick this one out, and you are having what? 3s2 and 3p5. So this should be your answer because of the valence shell. Assuming they just said, what is the total number of electrons? Then the answer would have been this. But what is the valence shell? The answer should be that. So do we have it in the option? Of course we do. Option C. So option C becomes the correct answer. I hope that is clear. Then let's see the next question. Question 21. Question 21. In question 21, we are asked that the shape of the hydrocarbon compound CH4. It's obvious that CH4 is what? A member of the alkanes, methane. Then they said the shape of the hydrocarbon compound CH4 is A. Square planar, B. tetrahedral, C. planar, D. linear. Now, for the members of the alkanes, the shape of alkanes is what? Is tetrahedral. So all the members of the alkanes are tetrahedral shaped molecules. So since it is CH4 and methane is with that formula, then the correct option will be what? Option B as your correct answer. I hope that is clear. Next question. Question 22. Question 22, we are having hydrogen bond can be found in dash. Now, let me tell you guys something. Bonding, we have 2 divisions. Now, we have the intramolecular bonds, and we have the intermolecular bonds. Now, intramolecular bonds, they are bonds that exist within molecules, while inter, they are bonds that exist between molecules. Take note of that too. Keywords: within and between. All right. Now, bonds that are present under the intra are, we have electrovalent bond, also called ionic bond. Then we have covalent bond, and we have metallic bond. So these are the bonds under the intra, and generally the intra are known to be strong bonds. They are strong bonds. Then while inter, they are known to be weak bonds. And what are examples of intermolecular bonds? We have the hydrogen bond, and we have the van der Waals force, which is seen to be the weakest bond. Then the hydrogen bond is the strongest intermolecular bond, and it is formed when hydrogen is covalently linked to highly electronegative elements. My code is FON, meaning that when hydrogen combines with any of these elements, there must be the presence of hydrogen bond. And what does that mean? If I pick F and I say HF, hydrogen in combination with F, this is called hydrogen fluoride molecule. If I pick O, H2O, there is hydrogen bond in water. If I pick N, NH3, there is what? Hydrogen bond in ammonia. So this is hydrogen fluoride molecule. If you should check the options, A, hydrogen sulfide, wrong. B, hydrogen bromide, wrong. C, hydrogen fluoride, correct. HF. D, hydrogen chloride, wrong. So the correct option is hydrogen fluoride in this case. I hope it is clear. Let's see the next question. Question 23. Which of the following substances is a basic salt? Now, this is taking our minds to salt. We have different types of salt. We have about 5. We have the normal salt, we have acid salt, we have basic salt, we have double salt, and we have complex salt. So these are the 5 types of salt. Now, for normal salt, they are actually salts that are formed when there is the complete replacement of the replaceable hydrogen ions of an acid by a metal. So classical examples includes, we have the NaCl, we have the KCl, we have the Na2CO3, we have the KNO3. All these are normal salts. What about acid salt? Now, for acid salt and basic salt, I will just treat them at the same time. You can easily identify your acid salt when you have H at the middle of a salt compound is acid salt. When there is H at the middle, acid salt. When there is OH at the middle, basic salt. That's a code. So any salt that has H at the middle is acid salt. For example, if I write NaHSO4, if I write KHCO3, so long there is H at the middle, that's acid salt. But if there is OH at the middle, for example, MgOHCl, ZnOHCl, all these are what? Basic salt, because there is OH at the middle. That's how you can easily identify your basic salt. What about double salt? Now, double salt, they are salts that contain 2 cations, meaning positively charged ions, and 1 anion, that's negatively charged ion. We have classical examples to be KAl, which is a very common example. Then if you observe, the 2 positively charged ions here is K plus and Al3 plus, which is coming from this and this, while the negatively charged ion is what? SO4 2 minus. So we have 2 positively charged ions and we have 1 negatively charged ion. You get the point? But the total number of ions in total is what? 3. So we have 3 total number of ions present in double salt. This guy here is called potassium aluminium tetraoxosulfate 6-dodecahydrate. That is known to be the IUPAC name of this compound, and the name is also known as potash alum. That's the common name, potash alum, double salt. What about complex? Classical examples of complex salts include, we have the Na2ZnOH4, we have the K4FeCN6. So when you see these two salt compounds, just know that they are examples of complex salt. So what did they ask us? Which of the following substances is a basic salt? Remember my code. Any basic salt must contain OH at the middle. So automatically you have to look out for the one that has OH at the middle. This is a normal salt, is wrong. This is obviously the basic salt because it has OH at the middle, correct. Then this is an acid salt, wrong, because of H at the middle. Then why this one is a double salt, wrong. So the correct option is option B. Let's see the next question. The next question is question 24. Question 24. In question 24, we are told phenolphthalein in acidic solution is, now firstly, phenolphthalein is an example of an indicator. Indicators, they tend to change color upon placed in different media. For example, acidic, basic, neutral. So phenolphthalein is an example of an indicator. There are 3 common indicators that they often bring questions on. And what are they? We have the litmus paper. These are indicators. indicators: litmus paper, then we have meter orange, and we have phenolphthalein. Then let me just show you guys their colors in different media. Let's say this is acidic, this is neutral, and this is basic, or you can call it alkaline. Okay, so the color of litmus in acidic is red, in neutral is purple, in basic is blue. Then meter orange in acidic is red, in neutral is orange, and in basic is yellow. Then phenolphthalein in acidic is colorless, in neutral is also colorless, but in basic is pink. So what was the question? The question is phenolphthalein in acidic solution is dash. So this is phenolphthalein. In acidic is what? Is colorless. So the answer is option A, colorless. So next question, question 25. Please take note of this, it's very important. Question 25. Question 25 says, which of the following salts can be melted without decomposition? So they are trying to let us know the solubility and stability to heat rules of triazocarbonate. Solubility and stability to heat of triazocarbonates. All right. Now, if you look at all the options, why I said triazocarbonates is because of the options. They all end with what? CO3. So, what are they asking us? They are asking that which of the following salts can be melted, meaning it is soluble, it can dissolve, and then without decomposition, meaning it is stable to heat, meaning when you apply heat, nothing happens to the salt. That's why they said without decomposition, it does not decompose upon heat application. So meaning it's soluble in water and stable to heat. Soluble in water and stable to heat is what we are being asked. But mind you, let us get the overview of triazocarbonates, talking about their solubility and their stability to heat. Let's see. For triazocarbonate, most triazocarbonates are insoluble in water. The only ones that are soluble in water are three. And what do you have there? We have sodium carbonate, we have potassium carbonate, and we have ammonium carbonate. These are the only carbonates that are soluble. They are soluble in water, while the rest are insoluble. So the only three that are soluble are sodium carbonate, potassium carbonate, ammonium carbonate. They are the only soluble triazocarbonates. Then while the rest are insoluble, meaning they don't dissolve. Then those ones that are stable to heat, the ones that are stable to heat are only three, and they are sodium carbonate, potassium carbonate, and barium carbonate. These ones are the only ones that are stable to heat, meaning that all others, when heat is applied, they decompose. The only ones that are stable are these three. So take note of that. Now, to the question, which of the following salts can be melted, meaning it is soluble and without what? Decomposition, meaning it is stable to heat. So we are interested in the one that is both soluble and stable. So if you look at option A is Na2CO3. Is Na2CO3 soluble? Yes. And is it stable to heat or unstable? It is what? Stable. So it appears at both ends. So the correct option is obviously option A. Because if you check this guy now, this one is what? Insoluble and unstable. Because it's not amongst these guys. This one, insoluble and unstable. This one, insoluble and unstable, because you can't find them here. So the only one that you can find here happens to be this. So that's the reason why this becomes the answer. So let's see the next question. Question 26. Question 26. In question 26, we were asked an equation given and what is the change in the oxidation number of copper in the reaction. Now, we have Cu2S plus O2 to give 2Cu plus SO2. Now, before attempting this question, I would advise that you should watch my video lesson I made on redox reaction, that's oxidizing and reducing agent. Do well to watch it on this channel. Now, looking at this, we were asked the change in the oxidation number of copper. So, looking at this reaction, the first step, my secret tip, is that when you check the reaction, anyone that has number before it, erase that number. So, do we have any number here? No, no. Then we have a number here, erase it. We don't have any number here, you leave it like that. That's the first principle. Then the second, we are told to calculate the change in the oxidation number of copper. Copper is here and copper is here. So you don't focus on any other thing. It's just the copper to the copper. Now, the copper changed from left. This is called left. The left part of the reaction to what? To right. So there was a change from left to right. So let's get the oxidation number of copper here. How do we get it? Copper appeared in this compound. So we write it out. Cu2S. What is the oxidation number of copper here? It's very easy. This compound obviously was formed when copper was Cu plus and sulfur was S2 minus. Yes, because these two came from the sulfur, while one came down here and nothing happened. So it means that the charge of copper here is +1. Then while this one is -2, these two came from this guy. So the charge is what we are interested in, because oxidation number is also called the charge an element carries. So the charge that copper carries here is +1. We have seen that. Copper here is just alone. It's not in combination with any element. Any element that is alone, that is in a free state, uncombined state, the oxidation number is what? 0. So this one is 0. So it means that there was a change in the oxidation number of copper from +1 to 0. So it means it moved from +1 to 0. Do we have that in the option? A, 0 to +1, wrong. B, 0 to +2, wrong. C, +2 to +1, wrong. D, +1 to 0, correct. +1 to 0. So that's the correct answer. For you to better understand that, just check my video class I made on oxidation number, especially oxidizing and reducing agents. The next question, question 27. A form of carbon used for absorbing poisonous gases and purification of noble gases is, these were the options. Option A, carbon fibers. B, animal charcoal. C, wood charcoal. D, carbon black. If you have studied amorphous forms of carbon, that's non-crystalline forms of carbon, this question should be a giveaway. How? Now, charcoal as an amorphous form of carbon, we have 3 types. What are they? We have the animal charcoal. We have the wood charcoal, and we have the sugar charcoal. Now, if you look at these different charcoals, animal charcoal is obtained by the burning of animal carcasses, like the bones, the blood, any material of animal. When burnt, you obtain animal charcoal. And the use of this guy is that it is used in removal of coloring matter. They use it to absorb coloring matter. Then the impurity obtained here is calcium tetraoxo phosphate 5 impurity. That's the impurity obtained from animal charcoal. Then that of wood charcoal. Wood charcoal is used in gas mask for absorbing poisonous gases, and not only that, in the purification of noble gases. The impurity found in wood charcoal is sulfur impurity. That's the impurity that is found in wood charcoal. All right. So it is used in the absorption of poisonous gases as well as the purification of noble gases. While sugar charcoal is the purest amorphous form of carbon. In case you see a question, The purest amorphous form of carbon is sugar charcoal. Is seen to be the purest amorphous form of carbon, alright, and it is obtained by the dehydration of sugars. When you dehydrate sugars, you can use dehydrating agents like concentrated sulfuric acid. After dehydrating sugars, you obtain a dark deposit of carbon in the form of sugar charcoal. So basically, the question is a form of carbon used for absorbing poisonous gases and purification of noble gases is, of course, the answer is wood charcoal. Wood charcoal. So let's see the next question. Question 28. Coal gas is made up of carbon 2 oxide, hydrogen and dash. Firstly, we have to understand what coal gas is and where it is coming from. Now, coal gas is actually one of the products obtained from the destructive distillation of coal. Coal is an amorphous form of carbon and it undergoes destructive distillation, meaning that it is the burning of a substance in the absence of air. That is destructive distillation. So when you carry out destructive distillation on coal, you are going to obtain 4 products. And what are they? We have coal tar, we have coal gas, we have coke, and we have ammoniacal liquor. Ammoniacal liquor. Alright, so amongst these 4 products, the only gaseous product happens to be coal gas, and that's where they are now asking question that coal gas is made up of carbon 2 oxide, hydrogen and dash. Now bringing out coal gas. Coal gas is made up of different gases, a mixture of different gases, but amongst these gases we have 3 main, and what are they? We have carbon 2 oxide, we have carbon 2 oxide, then we have hydrogen, and we have methane. These are the 3 main gases that make up coal gas. As a matter of fact, you also need to know their percentages. Now we have other gases too, like ethene gas, hydrogen sulfide is still part of it, but these ones are the main. By main, it means they carry the higher percentage composition of this coal gas, but there is one with the highest now, which happens to be what? Hydrogen. Hydrogen is about 50%. 50% of coal gas is hydrogen. Then after hydrogen, methane is next. Methane is 30%. After methane is carbon 2 oxide, which is 10%. So you must take note of their respective percentages. It's very, very important. Then while the leftover of the percentage goes to the other gases, ethene gas, hydrogen sulfide gas. So what should be our answer? Carbon 2 oxide, hydrogen and methane. Do we have methane in the option? Yes, option D. So that's the answer to that question. Then let's see the next question. Question 29. Question 29 says, hydrogen is readily released when dilute hydrochloric acid reacts with what? Normally, whenever acids react with metals, they tend to liberate what? They tend to liberate hydrogen gas and the formation of a salt. Alright, so acid to metals, salt and hydrogen gas. Then is it all metals that can liberate hydrogen gas from acids? No, it is only metals that are higher than hydrogen in the activity series that will be able to displace hydrogen from acids. Okay, so let's see. Let's check our ECS again, or activity series. You know, we have the cations and the anions, so we need to focus on the positively charged ions, being the metals. So let's just see a sketch. We have the first to be K plus, Na plus, Ca2 plus, Mg2 plus, Al3 plus, Zn2 plus, Fe2 plus, Sn2 2 plus, Pb 2 plus, then H plus, Cu 2 plus, then Hg 2 plus, Ag plus, and Au 3 plus because of the space. So all these ones are lower. You get the point now. So what do you notice? This is hydrogen. This is hydrogen. Hydrogen is here. Then let's check the ones that are lower. Looking at the question, we have gold. Gold is lower than hydrogen in the ECS. So gold will be wrong. Then we have copper. Copper is also lower than hydrogen. So copper should also be wrong. Then sodium. Sodium is way higher than what? Hydrogen. So sodium becomes the right answer. It's as easy as that. Then why silver is Ag. Silver is lower. So it's also wrong. So that's how you attempt questions like that. The one that is higher should discharge the hydrogen from, or displace the hydrogen from, the acid. All right. So the correct answer is option C, sodium. Then let's see the next question. In the next question, we are asked, an example of a neutral oxide is, now taking your mind to oxygen. Oxygen forms oxides, right? And we have different types of oxides. We have the acid oxides, we have the basic oxides, we have the neutral oxides, we have the amphoteric oxides, and we have the peroxides. These are the different types of oxides that we have. Acid oxides are oxides of non-metals. Basic oxides are oxides of metals. Then neutral oxides, they are simply oxides that neither possess acidic nor basic properties. Classical examples include water. Water is a neutral oxide. You know, pure water has a pH of 7. Then we have others like the dinitrogen 1 oxide, N2O, which is commonly referred to as laughing gas. And then we have CO, which is carbon 2 oxide. So all these are classical examples of neutral oxides. They don't possess acidic as well as basic properties. The amphoteric oxides, they possess both acidic and basic properties. Metals that form amphoteric oxides are, we have zinc, we have aluminium, we have tin, and we have lead. You understand? So zinc oxide, ZnO, aluminium oxide, Al2O3, tin oxide, SnO, then lead oxide, PbO. All of them here, they are what? They are amphoteric oxides. Then peroxides is where you have the oxidation number of oxygen to be -1. And classical examples, we have the hydrogen peroxide as a prominent member, even sodium peroxide, Na2O2, sodium peroxide. All peroxides, the oxidation number of oxygen there is -1. You know, in most compounds, oxidation number of oxygen is -2. Then except peroxides, which is -1. All right. So let's check. They ask an example of neutral oxide. We've seen these are the examples of neutral oxides. So we have CO there. So CO is the correct answer. All right. Then let's see the next question. The next question. That is question 31. Question 31, we were asked the constituents of baking powder that makes the dough to rise is, first and foremost, we have what is called baking soda. Many students, they mistake baking soda for baking powder. Now, we have baking soda and we have baking powder. Baking soda happens to be a compound. Is a compound, while baking powder happens to be a mixture. You understand? You know, it's just like you comparing urine and urea. Urea is a compound, urine is a mixture. Then in urine, it contains urea. You understand it now? It's just like sand and soil. Soil is a mixture, sand is a compound, but in soil you have sand. You understand? Same thing is applicable to this. That's baking soda is a compound, baking powder is a mixture. In baking powder, you have baking soda. You understand it now? So baking soda has the formula NaHCO3. which is sodium hydrogen carbonate, or you call it sodium bicarbonate. Is that you are calling it sodium hydrogen carbonate, or you call it sodium bicarbonate? Then baking powder is a mixture of this guy, which is sodium bicarbonate, NaHCO3 plus tartaric acid. Tartaric acid is an organic acid with the IUPAC name of 2,3-dihydroxyl butane dioic acid. That is the IUPAC name of tartaric acid. But the basic thing is this: in baking powder, there is sodium bicarbonate and tartaric acid. So what makes the dough to rise is obviously what? The presence of sodium hydrogen carbonate in baking powder, because when you heat this guy will release what? CO2 upon heating. Now when you heat this guy, NaHCO3, because all hydrogen carbonates are unstable to heat. Take note of that. All hydrogen carbonates are unstable to heat, meaning when you apply heat, they decompose. When I apply heat on this, I should obtain sodium carbonate, which is the ordinary sodium carbonate. I should obtain H2O, water, and CO2. So this gas that is released is what is responsible for making the dough to rise. Do you understand? So that's the answer to the question. Let's see question 32. Question 32. In question 32, we were asked, in the blast furnace, what occurs in the blast furnace? Now, the extraction of iron. Extraction of iron, okay, as a metal. The main function of limestone, the function of limestone is what they are asking us. But what's the formula? CaCO3, CaCO3. The function of limestone is to produce dash. Now, normally, limestone, the main function of limestone is to remove what? Impurity in the form of slag. First thing that happens is it decomposes. CaCO3 decomposes to form CaO plus CO2. Then CaO will now combine with silicon 4 oxide present as an impurity. So CaO, when it now combines with silicon 4 oxide, SiO2, then it would now form what is called CaSiO3. This is called slag. So basically, the main function of CaCO3, which is limestone, is to remove what? Impurities. All right. But then, what does it produce in order to bring about the removal of that impurity is what? CaO. CaO is called calcium oxide, commonly called what? Quick lime. Quick lime. All right. So basically, it is this compound that will be produced or formed from limestone. So in the blast furnace, the main function of limestone is to produce what? Is to produce calcium oxide that will in turn combine with this to remove impurities. All right. So let's see the next question. Question 33. The alkanol obtained from the production of soap is, first and foremost, we need to understand the process involved in producing soap. Production of soap is called saponification in organic chemistry. Saponification. And what does saponification entail? It is simply the alkaline hydrolysis, of fats and oils. You know that fats and oils are examples of esters. So the alkaline hydrolysis of fats and oils yields soap and glycerol, also called propan 1,2,3-triol. All right. So the two products that are obtained by saponification is soap and glycerol, while one is the main product, which happens to be the soap that you are interested in obtaining. Then glycerol is the alkanol that you are to obtain as byproduct. So looking at the options, which one is correct? Option A, ethanol; B, glycerol; C, methanol; and D, glycol. So it is actually what? Glycerol. Take note of that, it's very important. Then next question, question 34. Question 34 says, if an organic compound decolorizes bromine water, then the compound is, firstly, we have bromine water and we have acidified KMNO4, meaning acidified potassium permanganate or acidified potassium tetraoxomanganate 7. So these two compounds, the reason why I had to outline them is because they are used to test for unsaturation in organic chemistry 1. Now in organic chemistry 1, you have the alkanes, the alkenes, and the alkynes. The alkenes and alkynes, they are unsaturated, while the alkanes are saturated. So when using these two reagents or these two substances to test for unsaturation, it is only the alkenes and the alkynes that would give positive test to both of them. And what is the positive test? This guy, the color is reddish brown, while this one is purple. So if you use any of the unsaturated compounds on them, the color will what? Disappear, meaning they both get decolorized when treated with any unsaturated compound, confirming the presence of unsaturated compound. But when you use saturated compounds on either of them, nothing happens. Their color will remain. So that's to show that this and this are used to test for what? Unsaturation. Hence, it is only unsaturated compounds that can decolorize both of them. So the question is, if an organic compound decolorizes bromine water, then the compound is, the answer to the question is unsaturated. You can do well to watch my video lesson I made on organic chemistry. Do well to watch that video on this channel. It will be of help to you a lot. All right. So the answer is unsaturated. Next question. Question 35. Question 35 is, the flame used by welders in cutting metals is, now there is a particular compound of the alkynes. Now the first member is ethyne, and there is something special about ethyne. Ethyne is also called acetylene. That's another name for ethyne. Now ethyne, when burnt in oxygen, burns with a very high temperature of about 3,500 degrees Celsius, producing a flame which is called oxyethyne flame, or you can call it remember another name for ethyne is what? Acetylene. So you can call it oxyacetylene flame, which is commonly used by welders for cutting of metals and also for welding metals together. They don't only use them for cutting metals, also for welding metals together. So the correct answer becomes what? Oxyacetylene flame, option C. So that's our right answer. So let's see the next question, question 36. Question 36 says, the reaction of an alkanol with an alkanoic acid in the presence of concentrated H2SO4, meaning concentrated H2SO4 is functioning as a catalyst, will produce an, then these are the options. Now you have an alkanol plus an alkanoic acid The reaction is a reversible reaction, meaning proceeding in two directions. So the forward reaction is called esterification. Esterification. Why? A reaction between an alkanol and an alkanoic acid. Listen attentively. They might change this to be alcohol and change this to be carboxylic acid. Don't be confused when you see question like that. It's still the same thing. So the forward reaction is esterification, while the backward reaction is hydrolysis. So even from the name esterification, it means if you combine these two, you are supposed to obtain what? Ester and water as your products. Forward reaction. Esters are also called alkanoids. That's another name for esters, alkanoids. They have a general formula ROCOO. This is the general formula of esters. So another name for esters is what? Alkanoids. Then in the presence of concentrated H2SO4, remember I said that conc H2SO4 is functioning as a catalyst in the reaction. So what should be our answer now? Alkanal, alkanoids, alkanone, alkyne. It should be what? Alkanoids, because alkanoids are also called what? Esters. Hope you got that. Then let's see the next question. Question 37. Lucas reagent is used to test for dash. Firstly, we need to understand what Lucas reagent is. What is Lucas reagent? The composition of Lucas reagent is anhydrous zinc chloride, and concentrated hydrochloric acid. Anhydrous zinc chloride and concentrated hydrochloric acid, which is HCl. So these two substances make up Lucas reagent, and basically Lucas reagent is used as a reagent to distinguish the different classes of alkanols, meaning we have the primary alkanols, we have secondary alkanols, and we have tertiary alkanols. So Lucas reagent is used to distinguishing these three classes of alkanols. Now what will happen when you pass Lucas reagent through tertiary? There will be an immediate formation of cloudy solution or turbid solution. Immediate formation of turbid solution, cloudy solution, immediate. But when you pass Lucas reagent through secondary, it takes about 3 to 5 minutes of the formation of cloudy solution. Then that of primary, there will be no formation of cloudy solution under normal condition. The only way that you can get formation of cloudy solution is by subjecting the reaction to heat. So it means that you need to heat in order to get the formation of cloudy solution. So basically, under normal condition, this is what happens. That this tertiary gives immediate, secondary takes about 3 to 5 minutes, while primary does not form any cloudy solution. Alright, so basically the use of Lucas reagent is to alkanols. So do we have that in the option? Let's check. Option A, alkanol, alkanoic acid, alkenes, amines. So it's actually what? Alkanols as our right answer. Okay, so option A becomes the correct answer. Then let's see question 38. Question 38 is the principal constituent of natural gas happens to be the first member of the alkanes, which happens to be methane, with the formula CH4. Now methane is the chief or main constituent of natural gas and also the main constituent of biogas. So it's the main constituent of both natural gas and what? And biogas. Then again, methane is also called marsh gas. Marsh gas, that's another name for methane. Then we have another name again, which is fire damp. Fire damp. So marsh gas, the reason why methane is also called marsh gas is because it is found evolved or released in swampy environments. Then why that of fire damp? It is responsible for fire disaster or explosion in poorly ventilated coal mines. Alright, so basically methane is the chief constituent of natural gas. Option A becomes the correct answer. Then let's see question 39. In question 39, we are given the question, the reaction of ethanoic acid and PCl5 will give. Now, it is taking our minds to chemical reactions of ethanoic acid. Now, I'm going to split the board into two parts. We have the first to be chlorination, and we have the second to be reaction with phosphorus chlorides. The reason why I'm splitting into two parts is because of the nature of the options. That's the reason why I'm doing it like this. So that in case they want to twist question, you will know what to do. So be very attentive. Reaction with phosphorus chlorides. Now, phosphorus chlorides are two. We have the PCl5 and the PCl3, meaning phosphorus 5 chloride and phosphorus 3 chloride. Alright, then chlorination is the reaction with chlorine. Now, starting with chlorination, ethanoic acid is with the formula CH3COOH. Now, ethanoic acid would undergo a substitution reaction with chlorine in the presence of ultraviolet light to form what? To form, now this is what happens. You will remove one H here and you remove one Cl here. When you remove one H here and you remove one Cl here, you will form what? HCl. Then you are left with how many H here? CH2. Then that H that you removed, you will now replace with that leftover Cl here. You know, we remove one Cl, so we are left with one. You now replace it there, which is Cl, then what? COOH. Then you have to bring down this guy and it becomes CH2Cl plus Cl2. This is sort of a chain reaction. So you remove one H again from here, one H, and you remove one Cl here to form what? HCl. Then you should be left with what? Then CH, only one H is left. That one that you removed, that one H that you removed, you will now replace with what? The leftover of the Cl here. So when you now replace that leftover, you are going to be having how many Cl here? A total of 2. So Cl2, then what? COOH. Then you bring down this guy, CH, Cl2, then COOH plus, then we now have Cl2 again. One Cl will leave this place, one H will leave this place, which is the last H here, to form HCl. Then you are going to be left with what? C, then we don't have any H. So it will now be replaced with what? That Cl. So a total of how many Cl now? Cl3, then COOH. It stops there because we don't have any H that can replace. Looking at this reaction now, this you would call monochloroethanoic acid. Why? How many chlorine are here? 1. So monochloroethanoic acid. This is dichloroethanoic acid. This is trichloroethanoic acid. You get? So this is when you are carrying out a reaction with what? With chlorine. Chlorine in the presence of UV light. The reaction is termed substitution reaction. Then let's come to this place. PCl5. With PCl5, CH3, then COOH, reacting with PCl5. You are going to obtain 3 products. And what are they? You are going to obtain CH3COCl plus POCl3 plus HCl. This will be the 3 products you are going to obtain. Alright, the name of this compound is called ethanol chloride. Ethanol chloride. And this is the product that is common to this and to this. Meaning that whenever you use ethanoic acid to reacting with PCl5 or PCl3, the common product that you are going to get must be what? Ethanol chloride. Let's try that of PCl3. CH3 COOH, that's ethanoic acid, reacting with PCl3, phosphorus 3 chloride. Then we have to obtain what? CH3 again, COCl, that I said is common. Then you have to obtain what? H3PO3. This is called phosphorus acid. Now, if you want to balance, you just write 3 here and you write 3 here. The reaction becomes balanced if you confirm. But that's not our focus. Now, the common product is what? Ethanoic chloride to both PCl5 and PCl3. So, going back to the question, the reaction of ethanoic acid and PCl5, check. With PCl5, we obtain this. But with chlorine, we obtained all this. And if you check the options, this one is this guy with PCl5. Then this one, this, and this is with what? Chlorine. So what should be your answer? Your answer should be what? Option A. So I have to explain it so as for you to understand, in order for you to get your answer right whenever they ask question pertaining to this. If they want to twist it, know what to do. The last question, question 40. Which of these is not a condensation polymer? Now, it therefore implies that among these 4 options, 3 of them are condensation polymers, while only 1 is not. Firstly, we have to understand what polymerization entails. What is polymerization? It's simply the combination of small molecules which are called monomers. So monomers combine to form a large giant molecule which is called polymer. That process of combining small molecules to form a large molecule is now called polymerization. Polymerization. Alright? So these are the small molecules, don't forget, which are called monomers, while this one is the large molecule. The large molecule which is called polymer. Now, under polymerization, we now have 2 types. We have 2 types of polymerization. We have the addition polymerization, and we have the condensation polymerization. The addition polymerization is simply a type of polymerization that does not involve the elimination of any small molecules. Then for condensation, is simply a type of polymerization that involves the elimination of small molecules. Now, these small molecules can come in the form of water molecules usually. Alright, so what are classical examples of condensation polymers? Jamb loves to ask questions on this. In fact, it is even the question we are looking at. So examples of condensation polymers includes nylon and terylene. We still have others, but there's a reason why I'm enlisting just these 2, because Jamb loves to bring questions on just only these 2, especially under condensation polymerization. Then under addition polymerization, you have common polymers that you know, like we have the polyethylene, we have PVC, which is called polyvinyl chloride. Then we have polystyrene, we have polypropylonitrile. We have quite a number that are under the addition polymerization. But the 2 common examples of condensation polymers are these 2. Now, let me bring them out. For nylon, what are the monomers of nylon? Now, nylon has 2 monomers, and what are they? We have the first to be hexane dioic acid, Another name for this is called adipic acid. Then we have another monomer which is called hexan 1,6-diamine. So these are the two monomers of nylon. Another name for nylon is called polyamide. That's another name for nylon. Then what about terylene? For terylene, the monomers of terylene are, we have benzene 1,4-dicarboxylic acid. This guy is also called terephthalic acid. Then the other one that makes up terylene, the other monomer is ethan 1,2-diol, also called ethylene glycol. Okay, so these two are the monomers of terylene. Another name for terylene is polyester. So take note of that. So these two, they are what? Condensation polymers. But then they say which of these is not a condensation polymer? So this is a condensation polymer, so it's wrong. This is also a condensation polymer. Remember, we are looking for the one that is not. It's also wrong. Then next, we have protein. Would protein be a condensation polymer or an addition polymer? Let's find out. Remember that proteins are made from small molecules called amino acids. Now, we have the structure of amino acids to be drawn like this. This is the structure of amino acids. I want to show you guys whether protein is an example of condensation polymer. All right. So we have this. This is the structure of amino acid. And you can recall even from your biology lessons that there is a bond that connects at least two amino acids together. It is called peptide bond. So the bond present in protein is called peptide bond. So if you have an amino acid here and you have another, let's say I draw another amino acid, and then I'm having two amino acids, then I want to connect them together. And we have to what? And we have to interact the carboxyl group of one amino acid with the amino group of the other amino acid. When I now interact them together, I combine them together, then I will have to drag out something in order to form the bond. There must be something that should be eliminated before I form the bond. And what's that thing? Water. Meaning I'm going to take out OH from here and take out one H from these two H that we have here. So H2, you know this is H2. So if I take out one H here and I combine with OH, I've just eliminated what? H2O. You see it now? So H2O has been removed. What am I now left with? I am left with what? CO, which is this, and what? NH. CONH. That's what I'm left with here. Because I remove one H here and I remove OH here to form water. Then I'm left with CONH. Now this CONH is called what? The peptide bond. So CONH is called peptide bond. But don't forget something. Did I eliminate a molecule of water? I did. What did I define condensation polymerization to be? It involves the elimination of small molecules, usually what? In the form of water. So since I eliminated, and to form the bond, I needed to eliminate water, then such molecule that is ultimately formed, being protein, should fall under what? Condensation polymers. You understand? As a matter of fact, peptide bond is an example of amide. You know, in the world of organic chemistry, we have arrow NH2 and arrow CONH2. If you look at this one carefully, it resembles this. It doesn't resemble this. It resembles this more because there is CO. So hence it's an amide. So this is the general formula of amide. Why this is the general formula of amine. So, from what I've been able to explain here, it has been shown that protein is still what? An example of condensation polymer. So this is wrong. So the one that is not is what? Polyethylene. And polyethylene, from even the examples I have enlisted here, polyethylene is an example of what? Addition polymer. All right. So I hope that is clear. So we have come to the end of the series of Jamb 2026 REMA questions. I hope you guys really understood everything. It's with my hope and my prayer that as you are entering the hall to writing this exam, you will come out with outstanding results. If you believe that prayer, type amen in the comment section and God will confirm it for you. If you find this video helpful, do well to hit the like button, and if you are yet to be a subscriber of this channel, do well to hit on that subscribe button and also turn on that notification icon beside the subscribe button so that you will be the first to be notified whenever I upload quality content like this. I wish you guys all the best in your exam. God bless you and thanks for watching.